All right, welcome back. So first up with our generic triangle solving problems with trigonometry is the law of sines. So as we've just been mentioning there at the end of the right triangle video, we can't always use right triangle trig to solve it because it's restricted to only right triangles. If it's an obtuse triangle, it's an acute triangle, equilateral, whatever, we need to have other methods to solve out for different stuff. So the law of sines is one of those methods. So this is where we have the ratio of sine of the angle over its opposite side is consistent throughout the whole thing. So sine A over A, sine B over B, sine C over C are all going to be the same ratio throughout. So the idea is we're going to set up these ratios. We're going to be able to find three pieces of information that we'll know. Like we'll know angle A, angle B, and side A. So we can solve for side B. Or we'll know angle B, side B, and side C. We can solve for angle C. Stuff like that, where we cross multiply, solve out our problem from there. Make sure, again, you're referring to the video I put together for how we're using the calculus for the trig stuff to make sure you're typing in correctly as you're doing this stuff. Now, there's going to be three main cases we're going to use law of sines for, and you're going to recognize these cases from when you did geometry and you wrote your proofs for congruent triangles. ASA and AAS are both reasons to prove triangles are congruent. SSA was the reason you weren't allowed to use. We're actually going to discuss more about that and why you couldn't use that to prove congruent triangles here, as you're going to see in a little bit. So in both the ASA or AAS cases, you're given two angles. So always useful to kind of draw out the triangle. So we have angle A, angle B, angle C. Angle A is 52 degrees, angle C is 17 degrees, side B is 32. So if you're given two angles, we can solve for the third angle pretty quickly. Angle B has to be 180 minus 52 minus 17. So when doing that, we get 111 degrees. So there's our first missing piece of information. Now for side A and side C, this is now where law of sines comes into play. Because in order to solve for side A, I need to do sine of 52 over A, and I need to equal that to another ratio. Well, my three ratios would be sine 52 over A, sine 111 over 32, and then sine 17 over C. Now, as you can see, if I use the sine 111 over 32 for both those sine A and the sine C ratios, I'll be able to solve for A and C. So sine 52 over A equals sine 111 over 32. I cross multiply. 32 sine 52 equals A sine 111. We divide over the sine 111. So make sure you're careful typing this in. 32 times sine 52. Close off the parentheses, and then divided by sine 111, close off the parentheses. You're going to get A to be 27.010 with our thousandths place rounding. C, same idea. We would say sine 111 over 32 equals sine 17 over C. We cross multiply, we get C sine 111 equals 32, sine 17, divide over the sine 111, and that's again what we're typing in. Being careful with how you're closing off the parentheses for each of the trig functions, always. We're getting 10.022 for the value of C. All right, and again, if you're having issues typing out, you're not quite sure, you're not getting my decimals, you're kind of following along right now, make sure you are going, I would recommend really stopping this video, going to the trig video, and making sure you're getting what I had, following along with how I'm typing the stuff out there. It won't be obviously this problem, but I'll kind of write out a problem and then show you how it's typed out correctly. So that's how it works when I give you two angles. Subtract to get the third, set up two law of sine ratios to solve for that missing side. Now the ambiguous case side-side angle is called ambiguous because we couldn't prove it triangles congruent there. Because it turns out if I have two triangles with the side angle situation, you could create a situation where you actually don't even have a triangle at all technically. That's your no solution. You do have the one triangle, so that's where they would technically be congruent to each other. Or you have a situation where you have two completely different triangles. And obviously wouldn't be congruent then in that case. Now in those solution case will show up algebraically very noticeably. Assuming you type everything in correctly, you should get a number every single time you do your law of sines problem. If you get some sort of error message, you've made a mistake then. I'm sorry, you've not made a mistake. It's a no solution situation. Also, if you happen to notice the largest side is not opposite the largest angle, meaning like if I tell you like angle A is 100 degrees, side B is 25 and side A is 20, that's not possible. Because side B is bigger than side A, that means angle B must be bigger than angle A. But if angle A is already obtuse, that means B is also obtuse, and that can't be a triangle. So that's what I mean by the whole largest side not opposite the largest angle kind of stuff. Those are the two ways you'll notice a no solution. So assuming that's not the case, and assuming you don't get an error message, then how do you know whether it's 1 or 2? Well, it's one solution when the angle you're given is greater than the first angle you can solve for using your law of sines. And in the side-side angle case, you're always going to have to solve for an angle first, because you're given two sides and one angle. You have to get the second angle. So if that second angle you find is smaller than the given angle, there can only be one answer. If the second angle is larger than this given angle, then you can have a two solution situation. And the reason behind this is because the inverse sine function can only yield an acute angle result. Easy way to check this, if you were to do sine of 30, you get 0.5. If you do sine of 150, you also get 0.5. But if you try doing sine inverse of the 0.5 of the half, it's only going to tell you 30 degrees. It can't give you the obtuse answer. So in this case, you would assume the obtuse answer is possible, and you would just subtract it from 180 to find that one, and solve the resulting triangles based on those two angles you just found. So I'm going to show you one of each of those so you can kind of see what it's going to look like. So in all these cases, you're given two sides and only one angle. And if we kind of draw out our triangle here, we can see that if that's angle A, angle B, and angle C, angle B is 12 degrees, side B is 30, side A is 25. So the only thing we can solve for is angle A, because I know nothing about angle C or side C, so I can't use the law of sines with that, and there is no Pythagorean theorem if it's not a right triangle. So we would say sine of A over 25 equals sine of 12 over 30. We do the same thing. We would cross multiply, and we get 30 sine A equals 25 sine 12. We divide by 30. And again, anytime we're trying to solve for an angle, it's got to be an inverse function. So angle A would be the sine inverse of this 25 sine 12, where you have to close off your parentheses, divided by 30. And if this gives us an error message, it's no solution. If it gives us a number, we're going to compare it to the angle B and figure out which one is bigger to figure out whether there is a one or a two solution problem. And when we do this, we get 9.977 degrees. So that tells me, because angle A is less than the given angle, there can only be a one solution problem. So if it's a one solution, well, we need to use this value going forward. Now, this is not an exact value. We have to use the exact value of A to find angle C, and I have to use the exact value of angle C to then find side C, so we are going to store this. I would recommend storing it as, I just always store it as just A, because it's angle A. So I'm going to have it stored as A, and I'm going to use that going forward. So angle C is just simply 180 minus 12 minus angle A. So we would do 180 minus 12 minus alpha A, not typing out 9.977, 180 minus 12 minus the alpha A button on your graphing calculators. And doing that would give us a 158.023 degrees for angle C, which then needs to also be stored exactly as I'll call it alpha C then, because the variable is C. So the last thing to do is to solve for side C. So we would have to say sine of the 158, so sine of alpha C over C equals our sine of, I'll do 12 over 30. Let's stick with a nice number so I don't have to worry about the exact value of A doing alpha A again. Cross multiplying at C times sine 12 equals 30 sine C. So we divide by sine 12. So again, our calculator we type out is 30 sine alpha C, closing the parentheses, divided by sine 12, closing the parentheses. And we get side C to simply be 54. Kind of worked out nicely in that case. All right, so that's how the one solution problem is going to look. You're going to solve for the first angle, and if you get an angle that's less than what you started with, there is only one solution to worry about. If it was bigger, then there would be two solutions, and we'd have to account for that, and that gets a little messier. And we're going to see that with this next example right here. So for this one right here, we're recognizing that based on our triangle, A, B, and C. Angle A is 35 degrees. Side A is 20. Side C is 27. So we go ahead and solve for angle C first because we can't find anything about B yet. So that'd be sine of C over 27 equals sine of 35 over 20. Cross multiplying, getting 20 sine C equals 27 sine 35. Dividing over the 20, and then because we need to solve for the angle, it's now the inverse. So it's sine inverse of 27 sine 35, closing the parentheses of the 35, divided by 20. And this would give us 50.774 degrees. Now that's obviously larger than the first angle we had, so this now is our two-solution problem. Now here's how this is going to work. You need to store this because you need to use this exactly. So I'm going to store this as alpha C. So angle C1 is our 50.774 degrees, stored as alpha C. Angle C2 is going to be 180 minus angle C1 because it's going to be its supplementary angle. So 180 minus alpha C, not typing out 50.74, 180 minus alpha C is going to give us 129.256 degrees. And I need to sort that one exactly also. I don't want to sort it as A or B because I need to be able to use B later on, so I'm just going to call this D. All right, so those are our two possible answers for angle C, 50.774 if it was acute, or 129.256 if it was obtuse. So now the third angle, B1, is based on 180 minus 35 minus C1. Whereas angle B2 would be 180 minus 35 minus C2. And if you messed up and assumed that there was two solutions, but there really wasn't, what's going to happen is B2 would come out to be a negative answer. So then that's like, for example, the previous problem, if we had assumed two solutions for example 2, we would have gotten a negative answer for the missing third angle when we did that one. So that would just tell us automatically, no, there's only one solution. And again, we're not typing out 50.774. We're not typing out 129.256. You're doing the alpha C for C1, alpha D for C2. So B1 would give us 94.256 degrees, and B2 gives us 15.744 degrees. Again, I'm storing them both. I'm going to store B1 as B, and then I'll call B2 A. It doesn't really matter what variables you call which ones. So you can really use whatever letter you want. You can just kind of go like A, B, C, D, kind of down the list. I try to always store the variable as the associated letter, so it does match up nicer. Now that finally leaves us to solve for side B1 and side B2. So sine of 35 over 20 is the starting ratio. Sine of B1 over B1, and then versus the other options can be sine 35 over 20, sine of B2 over B2. So in both cases, we are going to have to cross multiply. So B1 sine 35 equals sine B1 times 20. We're going to have to divide over the sine 35. So B1 is 20 sine B1 over 20, over sine 35, sorry. Whereas B2 would be the same thing, but it's going to be 20 sine B2 over sine 35. Because after we cross multiply, it's the same concept. So again, we're not typing out the 94.256 for B1. We're not typing out the 15.744 for B2. We're using alpha B and alpha A. Doing that, side B1 is 34.773. And side B2 is 9.461. So there is obviously a lot going on. There's a lot of things you're going to have to be storing at them to keep your exact values throughout the problem and not have rounding errors as you're doing them. So just make sure you're careful with each of those setups. All right, so that was our two-solution case. Now let's take a look at the no-solution problem. And a lot of times no solutions can be fairly obvious at first glance. We see that side A is clearly bigger than side B. 21 is bigger than 11. It's much bigger. But angle B is already a pretty large angle. Angle B is 76 degrees. So my red flag is already up just by that, because that's a little too big for this to still work out. Now, if side B was 20 rather than being 11, that's a better chance of that being true then, because I could easily have a triangle that's 76 degrees and like, a triangle that has like, another angle that's like 89 degrees. Like that's perfectly fine. But the further away B is from A, the smaller angle B has to be for this to actually work out. So we're going to see when we set this up. We're going to do sine of 76 over 11 equals sine of A over 21. 21 sine 76 equals 11 sine A. Divided by the 11, and then do the sine inverse. And you're going to see when you do your sine inverse, 21 sine of 76 over 11, it's going to give you an error message. Again, don't always assume the error message automatically means it's no solution and it's not actually a triangle. Verify you typed everything in correctly. You didn't like drop a parentheses sign or anything like that. Just make sure it's all typed out the proper way. And if that is the case, then yes, you can trust it's no solution if it's the side-side angle problem. If it was the given two angles like from the beginning there, those will never be a no solution. So if you get an error message there, you messed up. But for given two sides of the angle that's not in between them, this can be an error message if the information given to you creates not a triangle. All right, so just make sure you're careful with those three possibilities, review them, go back if you do need to do them, and obviously, again, ask questions in class for that. So that's our law of sines. Law of cosines then covers some other relationships from our congruent triangles and how to solve out for a missing side. So I'll see you guys next time for that one.